Assalamualaikum and good day, my dear lecturer. My name is Ahmad Shazwan bin Abdul Maulud and my matrix number is B091910415. I'm going to present my final year project that is being supervised by Dr. Ridwan bin Jumaidin. My project title is Development of Biodegradable Packaging from Cassava Starch Reinforced with Coconut Fiber of Environmental Properties. The content of this presentation will begin with introduction, followed by literature review, and then methodology, and lastly, preliminary result. Firstly, introduction. Background. Most plastics are used for disposable purposes, such as items that are discarded with a year, increasing the material serious pollution problems. Although the vast majority of thermoplastics are recyclable, separating the elements presents significant restriction. As a solution, numerous environmental friendly materials such as starch have been developed to address this issue. Starch has recently become a subject of research due to its sustainability, vast availability, and propensity to decompose easily in the natural environment. In this study, aimed to develop biodegradable packaging from cassava starch reinforced with coconut fiber and improve physical environment properties. For problem statement, first, natural fiber such as coconut fiber is discarded in abundance. Second, the increasing of human activities harm the environment. Third, non-biodegradable products are causing environmental harms. Lastly, starch can be alternative to this problem but has poor physical properties. Next will be project objective. To prepare biodegradable thermoplastic cassava starch reinforced with coconut husk fiber composite. Second, to evaluate the water affinity properties and the environmental properties of the biodegradable thermoplastic cassava starch reinforced with coconut husk fiber composite. Lastly, to fabricate biodegradable packaging derived from coconut husk fiber and cassava starch. For project scope, first, glycerol and palm wax have been used to enhance coconut fiber and cassava starch, which serve as the basis for the final product. Dry mixing and hot pressing are used to create the composite. Third, soluble and water solubility testing are used in environmental testing. Fourth, the inner swelling, moisture content, and water absorption are some of the water affinity tests that will be conducted. Fifth, additionally, a scanning electron microscope will be used to examine the material's shape and density. Lastly, this study focuses on the utilization of three sizes of coconut husk fiber, which is 125 micrometer, 200 micrometer, and 300 micrometer. Next, literature review. For cassava starch. Cassava starch provides many important nutrients including resistant starch which may have health benefits. If certain circumstances are met, it can be converted into thermoplastic. For starch. Starch basically is humanity's primary food source. In this regard, the goal of this review is to offer important data on the health benefit of resistant starch consumption as well as its importance on psychological features such as intestinal health and body weight. Next, there are some thermoplastic cassava starch applications from different studies. From different types of polymer, it has potential to develop food packaging plastic, biodegradable tray, biodegradable polymer, and also biodegradable material. Next, thermoplastic starch. The thermoplastic starch deformation of starch is affected by the complicated structure of the natural polymer. Thermoplastic starch can be molded into a variety of products and blown into film. Improvement of a thermoplastic include the addition of natural fiber. For coconut fiber generally often known as coir, is extracted from the coconut fibrous husk. Coir fibers' high lignin contents make it extremely durable and long-lasting. There are two kinds, bristle and mestrous fibers. Coconut husks are most commonly used in direct burning to produce coal, charcoals, and otherwise there are discards. Coconut husks may be turned into a high-value fuel that can be used instead of wood and other traditional fuels. For glycerol and palm wax, first, glycerol basically are used on produced flavor and food colors are dissolved in glycerol. It also utilized in low-fat foods like cookies as plasticizer and filler. Glycerol is used for the processing and biodegradable starch film as a plasticizer. For palm wax is viewed as an inexpensive and environmental friendly alternative to hydrophobic chemicals derived from fossil fuels. In this study, palm wax functions as a protective agent against water absorption and moisture. The summary of literature review: first, inclusion of coconut husk fiber and palm wax will bring improvement for the thermoplastic. Second, knowing thermoplastic cassava starch from different studies with their application. Lastly, starch can be processed into thermoplastic starch. Next, methodology project. This methodology flowchart are to meet all the objectives, which are to prepare biodegradable thermoplastic cassava starch reinforced with coconut husk fiber composite. Second, to evaluate the water affinity properties and the environment properties of the biodegradable thermoplastic cassava starch reinforced with coconut husk fiber composite. Lastly, to fabricate biodegradable packaging derived from coconut husk fiber and cassava starch. Next, this is raw material that we'll use to conduct this project. First, coconut husk fiber. Second, cassava starch, glycerol, and also palm wax. This is extraction of coconut fiber process. First, retting process. Second, cutting the fiber into small pieces, and then grinding the coconut husk fiber. Next, isolate a coconut husk into fiber size. Fabrication of thermoplastic cassava starch reinforced with coconut husk fiber process. First, weigh all the mixture. Second, dry mixing for 3 to 5 minutes. Third, compacting all mold with the mixture. Next, place into the hot press machine for 1 hour. Lastly, specimen removed from mold. This is type of testing that will be conducted. First, moisture content, water absorption, thickness swelling, scanning electron microscopy, density, soluble, and water solubility. Lastly, for preliminary result and discussion. For moisture content, the purpose of this study is to assess the quantity of moisture in a sample of TPCS with coconut husk fiber. High moisture content has a negative impact on composite stability. As a result, a good composite fiber should have a lower moisture content. In terms of a preliminary finding, the lower value in moisture content testing is 1 to 5 micrometer. Expected result for others testing. For water adsorption, according to Muhammad 2018, when the volume of the fiber was doubled to 20% fiber content, the rate of water adsorption increased respectively. It is expected that for thermoplastic cassava starch reinforced with coconut husk will be discovered that when fiber content increase the rate of water adsorption. For thickness swelling, the swelling behavior of TPCS blend followed the same pattern as the moisture adsorption behavior. In this investigation, the swelling ability of the film decreased dramatically. Low swelling indices, on the other hand, are preferred for many applications since they indicate excellent water resistance. Next, SEM. It is predicted that as coconut husk fiber increased, the fracture surface was uneven and contains holes. This could be due to starch retrogradation, in which palm wax interfered with starch plasticization, leading to the formation of phase separation between thermoplastic cassava starch and palm wax. For density, according to Ahmad finding, the difference in composite density as fiber length increased in cement composite sample. The data show a small decrease in density as fiber length increased. For several, weight loss in all composite were greater after 4 weeks of burial than after 2 weeks. This result can be attributed to a higher number of microactivity occurring at a longer burial duration, which result in an increase in material weight loss. Lastly, water solubility. This lowers the hygroscopic nature of the biocomposite, and it should be noted that the water solubility of TPCS plus palm wax biocomposite decreased dramatically. It is also expected to rise due to addition of coconut fibers. This brings me to the end of my presentation. Thank you so much for your time.